Hello everyone. In this question, it is given that if ix be a function which is the integral of x plus 1 upon the product of x times 1 plus x times e to the power x whole squared, where x is greater than 0, and the limit of ix as x tends to infinity be equal to 0, then we have to find the value of I of 1. Okay, so basically this is an integral, and the answer of this integral is the function ix, and we are given a limiting condition from which we can find the value of this plus c. Okay, and after finding that plus c, we have to evaluate this value at x equal to 1. Okay, so let us start this integral. We are given the integral x plus 1 divided upon by x times 1 plus x e to the power x whole squared dx, right? So you'll see this term is a square term, and it also contains x and the product of e to the power x. Okay, so if I try to isolate this term in this integral, then we get 1 upon 1 plus x e to the power x whole squared times x plus 1 upon x dx. Okay, I've isolated it because if you take this term as u, there is a chance that you can get something like this. Okay, so let us see if we can get anything like this. So let us take u is equal to this entire term inside the bracket. Okay, 1 plus x e to the power x, so we get u equal to 1 plus x e to the power x. So from here, if we take 1 to the left hand side, we get u minus 1 is equal to x e to the power x, right? So now if we do derivative on both sides, we get du, and this is the product rule, right? ddx using the product rule, so it will be x times the ddx of e to the power x is just e to the power x plus e to the power x times the ddx of x is just 1, right? So this is e to the power x times 1. The whole thing is multiplied by dx. Okay, so we have du is equal to, if we take e to the power x common here, we have x plus 1 times e to the power x times dx. Okay, now we have x plus 1 upon x, right? So in order to get that, what if we divide both sides with x? Okay, here if we divide both sides by x, we get du upon x is equal to x plus 1 upon x times e to the power x dx. Okay, so we only have this x plus 1 upon x times dx. Okay, so if we isolate this part, x plus 1 upon x times dx, then we can divide both sides by e to the power x. Okay, so on dividing both sides by e to the power x, we get du upon x e to the power x is just equal to x plus 1 divided by x times dx, right? Okay, I have just divided both sides by e to the power x in this step. Okay, now we already have this x e to the power x is equal to u minus 1, right? So since we need to keep the right hand side in terms of x and left hand side in terms of u, we can use this substitution here. Okay, so we now get du upon u minus 1 is equal to x plus 1 upon x times dx. Okay, so these are the two substitutions that we can use here. Okay, so therefore our integral, which was x plus 1 divided by x times 1 plus x e to the power x whole squared dx, this now changes to this first part. This is just 1 upon u square, right? U was our denominator here. Okay, so this becomes integration of 1 upon u square times the remaining part, this part, x plus 1 upon x times dx. This is nothing but this, right? So this is du upon u minus 1, right? So this integral in terms of u is becoming something like this. Okay, 1 by u square times du upon u minus 1. Okay, so now this becomes du upon u square times u minus 1. So if we do a u square minus 1 or 1 minus u square plus u square here, and in the denominator we keep it as it is for the time being. Let us see what happens here. Okay, by doing some terms of partial fraction, if we can cancel a few terms or not, let us see. Okay, so if we keep it 1 minus u square together and this term is separate, then we can rewrite this 1 minus u square as 1 minus u times 1 plus u divided upon by u square times u minus 1 plus u square divided by u square times u minus 1, right? So I've just split this into two separate fractions. Okay, so now you see here 1 minus u and here is 1 u minus 1, so there will be a minus 1 here left out. Similarly, this u square and this u square cancel out, so we are now left with this becomes minus of 1 plus u upon u square plus 1 upon u minus 1 du. Okay, so now if we, for this first integral, if we separate each of these terms, we get minus 1 upon u square, and this will become minus u by u square, which is again minus 1 by u, right? And the last term is plus 1 upon u minus 1 du. So I believe this now becomes, first term becomes 1 by u, right? Since this is x to the power minus 2, so this will be x to the power or u to the power minus 1, and there is a minus here already, so this becomes 1 upon u, right? Then this will become minus ln mod u, and this will become plus ln mod u minus 1, right? Plus c. So now if we do the back substitution here, our u was 1 plus x to the power x, right? So this becomes 1 upon 1 plus x e to the power x, and here if we take these two logarithmic terms together, this becomes ln mod of u minus 1 upon u, right? So u minus 1, our u minus 1 was just x e to the power x, right? So this is x e to the power x divided upon by 1 plus x e to the power x, right? Plus c. I believe this is the result of the integral. Okay, so this is our ix, this is equal to our given ix. Okay, so now we are given that the limiting value of this ix as x tends to infinity is 0. Okay, so now we need to find the value of c using this condition. Since limit of ix as x tends to 0 is equal to 0, this implies that we have to apply limit x tends to 0 to the entire left hand side. Okay, so this is equal to 1 upon 1 plus x e to the power x plus ln mod of x e to the power x divided by 1 plus x e to the power x plus c. Okay, this is equal to 0. Now see, when we apply the limit x tends to infinity, this denominator term here, this denominator, it tends to infinity, right? So this becomes something like 1 upon infinity, right? So 1 upon infinity, this becomes approximately 0 because the denominator is very large, so this becomes 0, limiting value becomes 0. Similarly here also, this is essentially, this I believe cannot be said directly. Okay, I think we need to have some extra steps for this because this is essentially infinity by infinity here. Okay, so let us again continue. So this first term tends to 0. Okay, so I'm only considering this term here. So for this term, second term, we have x tends to infinity. For this term, we can rewrite it as ln 1 plus x e to the power x minus 1 divided by 1 plus x e to the power x. Right, I believe everything is correct here. I've added 1 and subtracted 1. Okay, so in the next step, if I split this, then this and this will cancel out and we are left with minus 1 upon this thing. Okay, and thus since c is a constant, this is outside the limit. Okay, so plus c is equal to 0. So now we have limit of x tends to infinity ln, this term becomes 1, so ln mod 1 minus 1 upon 1 plus x e to the power x plus c. Okay, so in this step, if we put x tends to infinity here, this is ln 1, so this will be 0. In this step, if we put x tends to infinity, this becomes something like 1 upon infinity, right? So this again tends to 0, limiting value tends to 0. We are left with ln 1 plus c. So on putting x tends to infinity, this just becomes ln 1 plus c equal to 0. Now again ln 1 is 0, therefore we get c equal to 0, right? So our value, this expression of ix now changes to one plus 1 upon 1 plus x e to the power x plus ln mod x e to the power x divided by 1 plus x e to the power x. Okay, so therefore our required question, which required I of 1, we just need to put the value of 1 here. Okay, so on putting the value of 1 here, we have, this becomes 1 plus 1 upon 1 plus, this becomes 1 times e, right? E to the power 1, so this becomes 1 upon 1 plus e plus this becomes ln first term in the numerator, this becomes 1 times e, so just e divided by 1 plus e, right? So if we further simplify it, we get 1 upon 1 plus e, and if I rewrite this as differences of two logarithms, this fraction, then we get ln e minus ln 1 plus e, right? Now ln e is just 1, so we have 1 upon 1 plus e plus 1 minus ln 1 plus e, right? So on taking LCM in these two terms, we get 1 plus 1 plus e. So this becomes e plus 2 by e plus 1 minus ln 1 plus e. Okay, so this is the required answer. Okay, in this question, in the four options given, I think these fractional values were changed, and this logarithm, before this logarithm, it was like plus ln this minus ln this, or it was e minus 2 upon e plus 1, something like that. So this is the required answer. Okay, the four options were very similar, the structures were something like this. Okay, so in this question, essentially the key step is using this separation of variables. Okay, while doing the u substitution here, I separated this x e to the power x term, because chances are, while if you differentiate this, chances are you will get something like this. Okay, so while doing this, I just basically brought in x in the left hand side, in the side of u. Okay, but in the final step I had to change it in terms of u. Okay, because while doing this integral substitution, you have to basically change the variables explicitly. That is, when you are changing x and dx, you need to keep the other side in terms of another variable separately. Okay, you cannot do it like du upon x e to the power x. You have u and x combined together. Okay, so that's why I had to separate this. And after doing this, I just used partial fractions while solving this part. Okay, I think 2-3 times I had to use this step, this partial fractions splitting. Okay, so this is the required answer. It was slightly lengthy and it was tricky in that substitution part, but other than that, this was not that difficult. Okay, so this is the required final answer. Okay, thank you for watching.